Hey everyone, and welcome. When we think about programming, it's easy to just picture lines of text on a screen. But really, at its core, it's this amazing tool for solving puzzles, both big and small. The real trick, though, is figuring out how you make that leap. That's the big question, isn't it? How do you take some messy, real-world problem, or even just a tricky logic puzzle, and translate it into a clean, simple solution that a computer can actually run? Well, that's exactly what we're going to dive into today. So here's the plan. We're going to tackle two totally different puzzles using Python. The first one is super practical, something you could genuinely run into. And the second one, it's a classic, more abstract logic puzzle, the kind programmers love to sink their teeth into. Okay, let's kick things off with our practical puzzle. Just picture this. You're at the hardware store, staring at a massive wall of paint cans. You need to paint a room, but how many cans do you actually need to buy? Guess too low, and you're making a second trip. Guess too high, and you've just wasted money. So what do we know? We've got a few key pieces of information. We know the dimensions of the wall, right? Its height and its width. And we can just look at the paint can. The label tells us exactly how much area it'll cover. So far, so good. Let's put some real numbers on this to make it clear. Let's say our wall is 12 square meters in total, and each can of paint we're looking at covers 5 square meters. This should be some simple division, right? And if we do the math, 12 divided by 5, we get 2.4. So there it is. We need exactly 2.4 cans of paint. Problem solved. Except, well, this is where we hit the real problem. Yeah, you can't exactly walk up to the cashier and ask for 4/10 of a paint can. They'd probably look at you a little funny. So what do? If you buy 2 cans, you're going to have an ugly, unpainted patch on your wall. We need a system, a rule that works every time. And that is a perfect job for code. This is exactly the kind of situation where programming just shines. We can write a really simple function in Python that not only does the math for us, but it solves that tricky rounding problem perfectly every single time. And here it is. This little piece of code is our paint calculator. It takes the wall's height and width and the paint can's coverage as its inputs. It calculates the area, and then it does one little magic trick to figure out the right number of cans. And this line right here is the absolute heart of the solution. This is what takes our calculation, that 2.4 we got earlier, and does something really clever with it. So what is this math.ceil thing? Well, ceil is short for ceiling. And just like the ceiling is always above you, this function always rounds a number up to the next whole number. So 2.4 becomes 3, and hey, even 2.1 would become 3. It's a guarantee that you'll always have enough paint. And that's it. Problem solved. All right, let's switch gears completely. We're going from the very practical world of paint cans to the very abstract world of prime numbers. This is a classic logic puzzle, a real brain teaser that forces us to think about what makes a number, well, a number. Okay, so quick refresher. A prime number is any number that's only divisible by 1 and itself. Numbers like 3, 5, 7, or 11. A number that's not prime, like 4, can be divided by other numbers, in this case 2. So the puzzle is this. How do you teach a computer to spot a prime number? We can't just give it a giant list of all the primes. We need to give it a method, a repeatable test that it can run on any number we throw at it. So our strategy is going to be a divisibility test. We're going to use a loop to systematically check every number that could possibly be a divisor. And along the way, we'll use a little true-false variable to keep track of what we find. Programmers often call this a flag. Okay, take a look at the code. We actually start off kind of optimistically. We create our flag, called isPrime, and we just assume the number is prime by setting it to true. Then our loop kicks in and starts trying to prove us wrong by running a test. Let's trace this with an example. Let's use the number 9. First, our isPrime flag is set to true. The loop starts. Is 9 divisible by 2? Nope, the flag stays true. Okay, next number. Is 9 divisible by 3? Yes, it divides perfectly. The instant that happens, we know it's not prime, so we flip our flag to false. The loop might keep going, but it doesn't even matter. At the end, the code checks the flag, sees that it's false, and tells us the answer, not prime. And just like our paint calculator, this puzzle also has one key line that does all the heavy lifting. This test, if number %i equals 0, is where the real logic is. And that little % sign, that's the whole secret. That percent sign is called the modulo operator. It looks a little weird, but all it does is give you the remainder of a division. So 9 modulo 3 is 0, because 3 goes into 9 with nothing left over. But 9 modulo 2 is 1, because there's a remainder. So if we ever get a remainder of 0 from any of our tests, we found a divisor, and we know for sure the number isn't prime. It's a fundamental tool in programming. So we've just solved two very different puzzles. What's the big takeaway from all this? Well, it's that learning to code is really about learning how to think like a problem solver. Think about it. For the paint puzzle, the trick was understanding a real-world rule, you can't buy half a can, and then finding the one perfect tool, math.ceil, to handle it. For the prime puzzle, it was all about building a logical process, a step-by-step test using the modulo operator. In both cases, the secret was just breaking the problem down into simple, logical steps. And honestly, this pattern works for pretty much any challenge you'll face in programming. First, you have to really understand the problem. Then, you find the right tool for the job, whether it's a function or an operator. And finally, you build the rest of your solution around that core idea. This whole process, this way of thinking, works for everything from paint cans to prime numbers. And that really just leaves one last question. Now that you've seen how it works, what little everyday problem in your life could you solve with just a few lines of code? Thanks for joining me.